Hi again, everyone. Chris Tisdell here again. Thanks for tuning in. In this presentation, I am going to continue my series of videos on matrices. We've been looking at the connections between matrices and systems of linear equations. In this video, we are going to look at the connection between a row echelon matrix and the solvability of a linear system. And we'll do lots of examples. Okay, so essentially the idea is to be given a row echelon form of a matrix and decide, well, is the linear system associated with that consistent, or is there no solution? Let me give you some examples, and I'll share my screen with you. All right, each of the following row echelon matrices represents a linear system. Determine whether each system is consistent, in other words, it has a unique solution or infinitely many solutions, or inconsistent, no solution. Okay, so how do we do that? Well, it's just a matter of looking at the columns of the matrix. Okay, so it's already in row echelon form. I've got some videos about that. Let's just consider the first matrix first. So this might be, 2x plus 3y plus 4z equals 11, and so on. 0x minus 3y plus 2z equals 7. Each row represents a simplified equation. All right, now you can see here that each column contains the first, each of the columns on the left-hand side of the big bar here. Each column contains the first entry of each row, or of some row, right? So column 1 contains 2, that's the first entry of row 1. Column 2 contains -3, that's the first entry of row 2. And column 3 contains 4, that's the first entry of row 3. All right, so all of the columns on the left-hand side are leading. Okay, all the columns on the left-hand side of the matrix are leading. And this column here, it doesn't contain any of the leading entries for any of the rows. So column 4 is non-leading. Okay, so what does that mean? Well, you can kind of work it out. From row 3, it says 4z equals 8, say. So z equals 2. You can back sub that into there and get y, back sub that into there and get x. So there is a unique solution. One and only one solution. Okay? Let's have a look at this matrix now. All the zeros at the bottom, no problem. It's in row echelon form. Let's have a look. Let's look at the columns, okay? The first column contains the first entry of row 1. Okay, no problem. So column 1's leading. Column 2 contains the first entry of row 2. Column 3 contains the first entry of row 3. So each of our columns are leading. And column 4 is not leading. So this is the same situation as up here. So I'm just using that to say this is the same. So a unique solution exists. All right. Okay, let's keep moving. Let's look at this one. Okay, that's in row echelon form. This column's leading. This column's leading. This column's leading. This column is not leading. Okay. So what does that mean? And this column is not leading. Okay, so there's at least one column on the left-hand side that's not leading. All right. So C1, C2, C3, C4 are leading. C2 is not leading, as is C4. So C4 is also not leading. Hence, what do we conclude? Infinite number of solutions. So it's still consistent, but there's more than one solution. Okay. All right, let's keep looking at the columns. That's a leading column. That's not. That is. That's not. That's not. Okay. So it's the same as actually case 3. Infinite number of solutions. All right. So in all of these cases, the linear systems are consistent. What about this one? This is one I've just drawn in. Okay. That's a leading column. That's a leading column. That's not. That's not. Okay. But what you can see here, so this column, C4 on the right-hand side of that line is leading. Okay. So C4 is a leading column because it contains this entry, which is the first non-zero entry of say row 3. What do we conclude that there's no solution. Okay, and you can kind of verify that just by looking at the bottom row. It says 0x plus 0y plus 0z equals 6. So 0 equals 6. Obviously that can't happen. Okay, so I've gone through those. There, hopefully you get some idea of what is required there. And this is a lot, but it's just a little summary, right? So to solve a linear system, we write the system as an augmented matrix and you row reduce it. Okay, and there's 2 cases. If the right-hand column is leading, right, like it was here, then the system has no solution. It's inconsistent. If the right-hand column is non-leading, here, 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 and here, then the system does have one or more solution, and then we can narrow it down to a bit more. We have the following possibilities. All the columns on the left are leading, and so the system has a unique solution, like those 2. Some columns on the left are non-leading, so the system has infinitely many solutions, like that and that. Okay, that was non-leading, that was non-leading. All right. In this case, we set a parameter to each of the non-leading variables, if there are any, and we use back substitution to get the solutions. Okay, now that's quite a lot of information, but the secret with mathematics is that it's not a spectator sport. You don't get good by watching. You get in there and you got to participate and do it. Okay, so the more of these things you look at, the better you'll get at it. Anyway, what do you think? If you have any comments, any questions, you can always put them in the comments section. Thanks again for watching, everybody. Bye.